So today's topic is about having a fit problem. Let's not throw a fit yet. As you can see from the subtitle, it's called it's about item fit. First, I want to say, remember last presentation when I talk about ECD, evidence center design. I told you guys I had a hard time trying to stay awake at class. But item fit is something I have to force myself not to think about it at night. Because if I think about it, I get excited. I couldn't go to sleep. And the next day I might be late. Okay, so alrighty, so this is it. So the outline, so it's we have three parts. First, we are gonna have some psychometric warm-up. I think it's always nice to warm up some introductory measurement knowledge. Then we talk about the meat of the presentation, item fit investigation, what's the problem we have. Then as always, I think it's not enough to just point out we have problems. We need to come up with a constructive advice. Otherwise, it's always easy to poke around and say, this is not good, what are we gonna do? Okay, so this is a three-part. Alrighty, let's get to the first part, psychometric warm-up. You guys know this picture, right? By the way, Dr. Harum told me he really hated this picture. He wanted to pay me to change the picture. I said no, as a psychometrician. Oh, really, Dr. Face? Okay, so, we'll talk after this. Maybe I'll change it to some baby. We have plenty of baby pictures later, so as you will see.
Yeah, he's coughing, so.
Oh, he's panting. I think he's doing heavy exercise. Alrighty. So first I want to talk about the classical measurement framework we ever use. This is a classical test theory. This is proposed by Spearman almost 100 years ago. So this is really a rather simple model. As you can see there, it has two parts. We have a true score, which is T, and a random error. And the X is our observed score. So think about a student take a test. We have, his total observed score, that's X. Then we have a true score, then random error. And we don't go to the item level, okay? That's why we have the test theory, it's like item theory. And the second formula there, we have, this is saying like the total variance, the variance of the observed score is composed of two parts. The true score variance and the error variance. And then we come to the third formula, is saying this is the classical definition of reliability. When we talk about reliability of a test, that's the ratio of the true score variance, in proportion to the observed score variance. So CTT is just, it's rather simple mathematically, but as like any other model, it makes assumptions. So basically, we have three assumptions here. First, errors are random and have a mean of 0. The same like in regression. We assume our errors are, have a mean of 0, and so normal distribution with a mean of 0. And the true score and the random errors are not correlated. That's important. That's why we can have the reliability, the true observed score variance as just two sum. If they are correlated, we are going to have covariance there. Okay, so they are not correlated. And errors in different tests, they are also not correlated. So independent random errors. Okay? So CTT, this is CTT. And the shortcomings of CTT, this is nicely summarized by Hamilton and Swaminathan in their 1985 classic IRT book. We have five shortcomings. They summarize that. First, item statistics, they are sample dependent. So think about p-value. Okay, a test is taken by two group of people. One is low ability, one is high ability. The p-value, one is 0.4, one is 0.7. Okay, it's sample dependent. And there is no way, like later on I'm going to show, like in IRT, you can linear transform that to put them on the same scale. Not in CTT, okay, at the item level. And second, comparison of examinees can be difficult if they do not take the same test form. It's not like IRT. IRT, we can definitely do that, right? So this is like, if they do not take, tests with the common items, equating is not even going to help us. Okay, it provides no basis for determining how an examinee might perform with a new item. If you think about this is why, like, when we talk about computer adaptive testing, we have to use IRT. Because there, we get an ability estimate to kind of predict what kind of a suitable item they should have next. So it's a prediction there. With CTT, it's not possible. It's not possible. And it assumes that the standard error of measurement is the same for all examinees. Okay, so no matter where their ability lies, it's all the same standard error. But with IRT, we see it's conditional standard error. Because usually in the middle you have the smallest error, and at the two extremes you have very big error because you don't have enough items to cover at those two extremes. Okay, but this is a very, very stringent assumption of CTT. And it is inadequate in test design, test bias detection, and test equating. Let's talk about test design. Nowadays we have computer adaptive testing, multi-stage testing, linear on-the-fly testing. All of those rely on IRT. With CTT we cannot do that. And in terms of test bias detection, maybe we can use a mental hazel, but mental hazel can deal with uniform. When it comes to non-uniform, it cannot. And also equating, IRT, like, the kind of equating we use here, what proposed by Professor Dimitrov, is also based on IRT. Is also based on IRT, the delta score. Okay, so those are the 5 shortcomings of CTT. And, okay, now let's come to its modern, successor, is IRT, item response theory. Actually, IRT was actually proposed by Lord in his 1952 monograph. Okay, that's first proposed. But it didn't become really popular until like in the 80s. We have enough computing power and the advance of, statistical algorithm, that's like start become popular in the 80s. But now I think it's no exaggeration to say IRT is like a mainstream, like a dominating measurement, paradigm. So the definition, IRT is a family of mathematical models that relates an examinee's response tendency or probability to his or her ability and item properties, by which we mean, like item difficulty, discrimination, guessing or slipping, those things. And in contrast to CTT, IRT allow us to focus on individual item. That's why we have the item as the first word, other than the whole test. Which is why Howard Weiner, he called classical test theory test response theory. Okay? In contrast to item response theory. It focused at the test level, but IRT led us to decompose the test into single items and look at them, each of them individually. Okay? So, let's talk about some familiar IRT models. Here we just focus on the dichotomous IRT models. By dichotomous, I mean like we just score the item as 0 and 1s. Okay? This is what we do here because all the items we have is multiple choice. Maybe later we're going to have polytomous ones, right, Dr. Shamrani, like language testing, like essay scoring. But that's a different issue. Today we focus on the most simple, like dichotomous model. So the first one is like a Rush model. You guys are already probably very familiar with this. This is saying like a person I's response to item J is a function of this logistical, regression thing. And let's have some picture here. So, this picture, in the IRT, we call that ICC. Item characteristic curve, which is say, on the horizontal axis, you have the ability. On the vertical axis, you have the probability of getting the item right. So this relates their ability to their correct response probability. So if you look at those ICC, if you have several items put in the same graph, if they never overlap, never intercept, that means they are 1PL model. Because why? All their discrimination parameters are the same. In Rush, they can be 1. In 1PL, you can force them to other values, but they have to be the same. That's why they are kind of like parallel. Okay? And another thing you notice that ability here, when your ability, reach really low level, your probability of getting it right is gonna approach 0. Okay? Because we don't have a guessing parameter here. That's why it is like that. Okay, this is our Rush model. Okay, the second model is a 2PL IRT model. As you can see, the only difference in terms of formula is that we have this, discrimination parameter there, A sub J. So notice the subscript J is saying every item has a different discrimination parameter. As a result of that, you see they kind of, intersect here, you see? And if you can read that, the first item, the red line is the discrimination parameter is 0.8. The second, the blue one is 1. The third one is like 2. This is discrimination. This is analogous to like in factor analysis, factor loading. This is really analogous to that. Okay? And this is a 2PL model. But same as 1PL, your ability goes down, it's always going to reach zero. So you have no chance of getting the item correctly. This is the property of a 2PL. Okay, now let's look at 3PL IRT model. So it's almost like the 2PL with the introduction of a C parameter. We call that guessing. But be careful, like in psychometric literature, they are saying guessing is not accurate. Either you call it a pseudo guessing or lower asymptote. So if you are like submitting a journal article, you put a guessing parameter, 9 times out of 10, reviewer is going to say this is wrong. Change that to pseudo guessing or lower asymptote. Okay? So as a result of the introducing of this guessing parameter, you can see no matter how low their ability go down to, they always have a probability of getting the item correctly. That's because of this C parameter. Okay. If you think about this guessing parameter, Lord, the Frederick Lord said that you can propose, say, for our questions we have 4 choices or multiple choice. You can think of it as 1 divided by 4 is 0.25, but that's based on random guessing. And based on lots of empirical data analysis, it's never like that. It's usually larger than that. And this is the same because they tend to have some partial knowledge, so they can rule out some distractors. So it's not always 1 divided by the number of options. Okay. Okay. So this is a model the center we use here. Okay. This is our baby here. So those are a very short introduction of those are the 3 classical dichotomous IRT models. Okay, I think I mentioned this before. I think it's worth reiterating, like item factor analysis, IFA and IRT, they are mathematically equivalent. Okay, so if you check out the Takei and Deleuze 1987 psychometric paper, it laid out not just for unidimensional, for multidimensional, they are mathematically equivalent. You can actually use formula to convert those. And also Kamata and Bauer in the SEM teacher corners paper talk about that. So if we use M plus here, if you look at the chapter on confirmative factor analysis, you run a single factor, analysis with dichotomous data, it's gonna in the output, it's gonna automatically give you both factor loadings and item parameters. It's automatically gonna be there. Okay? And a 3PL IRT model, due to the introduction of the pseudo guessing parameter, does not correspond to item factor analysis. So there is no correspondence. I think that the newest version of M+, now they can estimate a 3PL IRT model. Before that, no, because they don't consider it fall into this item factor analysis, umbrella. So I think this is something we should be aware of. So next time if you wanna, calibrate item data, M+ is an option if we are gonna use 1PL or 2PL, even 3PL now. But Professor Dimitrov said that 3PL estimation M+ is not satisfactory, right?
And nobody in the M+, we have 3 and 4 parameters.
Okay, but you said that you are not satisfied with the results. You told me once. Okay.
How do they do it? I mean, how do they implement the 3PL in the new version?
Well, basically, I believe they use the marginal maximum likelihood estimation. So it doesn't fall into this same item factor analysis paradigm. Same as other software.
Yeah, that's what I wanted to say, that it is possible. It is possible to do. You can also implement 3PL with the item factor analysis, not in the classical framework, but in the Bayes framework, you can do it.
Yeah, they have a Bayes estimator. Yeah, definitely it can be done. But in operational testing, this 3PL model is very difficult to converge. This C guessing parameter is a bad boy. It happens in the states a lot. Lots of state testing, they cannot estimate the C. They have to force it to be 0.25. They do that a lot. Okay, so this is our ORMA. Okay, next, IRT we have assumptions. This is based on D. Ayala. I think there's a nice IRT introductory book. So we talk about basically 3 main assumptions. First is unidimensionality. So this corresponds to our unidimensional IRT model. What does it mean? This, if you look at the formula here, this theta, this ability should be 1 dimension. So let's put it in a context where this assumption might be violated. See, imagine if we have some math question. This math question is not just formula. We have lots of verbal description. So for examiner needs to answer that question, he or she might need a combination of math and verbal reasoning. So in that case, we think this unidimensionality assumption is possibly violated, okay? Okay, so, this is the first assumption. Second is local independence. What do we mean by local independence? It's saying like examinee's item response is only driven by his ability, which we are interested to measure, okay? So if there is something else also, driving his response, we think we have a violation of local independence. In that case, we call that local dependence. If you think about, I think I did a presentation on the passage effect before. So if we have a really passage about some really like technical stuff, for the students to answer those reading comprehension questions based on that passage, they might need those background information. In that case, local independence is violated. So that's why we need to check some of those, okay? And the last one is that the functional form assumption. What do we mean functional form assumption? If we go back to this, if we look at the ICC, one thing I forgot to mention is that, if you look at it, that we call that monotonic, which means if your ability increases, your probability of getting the item right always increases, okay, monotonic. And also the empirical data we observe should also align well with this. Otherwise, RT model assumption is violated. We might not be able to, to collect the benefits of that. So those are the three things. And I think our item fit aligns well with this functional form assumption. And okay, so let me give you some example of this, the idea of item fit. So this is like a real item. So if you look at the blue line, this is our ICC, okay? This is based on our model, our, the RT model, the 3PL model we fit. So based on this model, so if a student has ability like this, his corresponding probability should be, somewhere lying on the blue line. And the red dot with those dash line, it's not red dot, it's a black circle with the red dash line, okay? And those are the empirical data we observed. So the idea of item fit is that along this ability continuum, this should match, okay? But as you could tell, it's never gonna perfectly match. Okay, so the item fit is to check the discrepancy between the ICC and the real data. If they depart from each other drastically, we might have a problem. We might need to think of a different item response model, or delete the item. So this is the item fit idea. Check the ICC, its discrepancy with the empirical response curve. We call that empirical response curve. So this is considered like a fit item, okay? And if you look at this, I'm gonna get to there, okay, Dr. Leo. It's in all the item calibration software there, okay? It should be there. It's like a regular thing we should check. And let's look at this item, okay? As you can see from the title, it's an example of a misfit item. We have big problem with this. First, you can see it really departs from the blue line. Then another problem is not monotonic, right? So you can see from the peak there, your ability increase, your probability of getting right decreases. We might have a fairness issue, right? In this case, okay? So we need to check that. And as I will show later with the traditional CTT, you cannot always tell. Okay, we need something like this. Okay, we need something like this. Okay, so let's talk about some traditional item fit statistics, some procedures. Okay, the first one is proposed by Yin, like it's Q1. So the idea of this, basically the idea of this is that you look at, back to our thing like this, you divide this ability continuum into 10 intervals. Within each interval, you look at the model predicted probability and their empirical, within that interval, how many of them got it correctly, okay? And you sum them up, you get this statistics is theoretically chi-square distributed, okay? It's a chi-square distribution. This is Yin's Q1 statistics. And we have another one. This is box chi-square based on his 1970 psychometric paper. So this idea is the same as Yin's Q1. The only difference is Yin used 10 intervals, and Bach you can use as many as you want. Okay? Okay, you can use as many also. Actually, this is a very arbitrary decision. And our Excalibur uses this one. Okay, our Excalibur uses this one. Then we have some other similar things proposed by those guys. It's called a G square, but it's also chi-squarely distributed. But anyway, the whole idea is that we are going to look at the ICC and look at the empirical response curve and to see where the discrepancy is statistically significant. That's the whole idea. That's the whole idea. Okay? Okay, so let's look at the, so those are, we call that traditional. So we have modern ones. There must be a problem with those. Let's look at what's the problem with them. Okay, first one, how to group examinee is sample dependent. Different cutoff points and different number of groups result in different statistics. So imagine here, like I have some example here. So we have this, ability continuum from -3 to 3. So whether we divide it into 10 or 20, it's gonna make a difference. It might change our test statistic. It might become, fit to unfit. So that's one problem with the traditional thing. And another is, computation of O sub k. So this is your observed probability of getting the item right. Requires the ability estimates, and hence, this O sub k is model dependent. Let me give you, I try to, to explain this a little bit better. So imagine we have, we divided our ability continuum into 10 interval. So the first interval, let's look at this interval here. It's from -0.24 to -1.8, okay? Based on the IRT model, we can calculate the predicted probability. But if we look at observed is also based on those ability estimates. This is well known in statistics. So in that case, your observed thing is not purely observed. It's also based on your model. In that case, your chi-square distribution, the degree of freedom is not clear. Okay? Okay. Don't be scared. I will try to explain on the next 2 slides. Okay? So let's look at an example of standard normal distribution. Everybody's familiar with it, right? We do like a z-score, right? If we have a z-score of 1.96, we think it's significant. Why is that? Here I have an example here. If you look at this, we have this, the standard normal distribution. If your z-score is 1.96, so the remaining area, it's 0.025. It's two-tailed. They add up to 0.01. That's what we mean by at alpha level at 0.05. But, with the standard normal distribution, it's very easy because we only need to know it's standard normal, okay? But with our item fit with chi-square distribution, you can see I mentioned that with the traditional statistics, our degree of freedom is not clear, which means if you look at those chi-square distributions with different degree of freedom, you see the distribution is very, very different. So we don't know which one to use. That's the problem with those traditional ones, okay? Unclear degree of freedom. Chi-square distribution is special in that case. It's very different from the standard normal, okay? So as a result of that, those guys, Thiessen and a student Orlando, they published a very influential paper, like in APM in 2000, called S chi-square. So this is the same as, it's very similar of Yin's Q1, but with the only difference, if you read the thing here, remember back then, when we say observed probability, it's not really observed, it's model dependent. But in this case, what they do, they really make it observed. They only look at those examinees with raw score, okay? So imagine we have a 20-item test. They divide it into 19 groups. First group is from score 1 to 2. So those are really pure observed score. So the bottom line is this one is theoretically superior. It's superior. And it's not implementing our Excalibur, okay? The bottom line is this one, the bottom line is here. Sorry, I kind of bore you guys with this technical, but I feel I have to, explain that a little bit. Various simulations have shown that unlike its predecessors, S chi-square has nominal type 1 error control rate and high power. And it is no exaggeration to say this has become the industry standard for evaluating item fit in non-rush IRT model. In rush, we have in-fit, out-fit, that's a different issue. And it has been implementing those new software, IRT Pro, FlexMert. But unfortunately, not in Excalibur. That's why this girl is having a grumpy face. Okay, it's not in Excalibur. Okay, it's not in Excalibur. I don't know why they are not implementing that, because as you can see, it's proposed in 2000. It's proposed in 2000. Okay, and
just to be clear, so what you're saying is in Excalibur, the observed score is not the sum score, or it's not.
yeah, it's based on this IRT ability estimate. So it's not really observed score. It's model dependent. Okay, okay. So this is S chi-square is what I'm gonna use. I think, like I said, is industry standard for non-rush model. Okay. So let's now. I think that's enough of a warm up, and hopefully everybody's still awake. Now let's get to the second part. I'm sorry I feel I have to go through the technical part. I don't fit in, our get verbal part. Okay? So first, why is item fit important to NCA? This scoring proposed by our Professor Dimitrov, this EPM paper, if you want to get a good D score, it relies on accurate estimation of IRT parameters in this 3PO IRT model. Okay? We need to have accurate item, IRT parameters. Okay.
One correction to give a heads up. There's a new development, new procedure where we evaluate the deltas without IRT at all. So this problem is.
You see, that's why I cited your paper there. That's based on your paper, you see.
Yeah. But now I said.
Okay, yeah.
We have now new development, and,
but
which I illustrated actually to you.
yeah, but that doesn't get around the problem that the items should also fit the model, right? That's no getting around that, right? No matter how you approximate this thing, it has to fit the model, right?
No, I don't have to fit the model.
You don't have a model to fit? Okay. In that case, we'll see your new published paper. Maybe you can educate more anyway. Okay, inshallah. Okay. So if there are a large number of misfit items in the test developed by the center, item parameter estimation will be compromised, and the validity of the delta scoring will be threatened. Okay, as you can. And the third issue I mentioned in the example of a misfit item, item with non-monotonic functional form presents a fairness issue. Okay, imagine their ability increases, their probability of getting right decreases. Okay, so that's a fairness issue there. We have to, we definitely have to find out what is going on. So here I did a comprehensive investigation of GATV. What do I mean by comprehensive? First, I feel one data set, one test does not suffice because it might not represent the general item fit situation in GAT verbal. Okay, so that's why I chose 25 GAT verbal tests and analyzed all of them. That's all the GAT data set I have on my computer. That's why I chose 25. It's totally arbitrary and random, okay? And I summarized the number of misfit items flagged by this Orlando Thiessen statistics. Okay, so let's go to the next slides. And before I do that, I want you guys to calm down and do not throw a fit yet. Okay, until I finish my story. Okay, so this is based on as you can see, there's a number of misfit items in GAT verbal. Okay, so we have the horizontal axis, we have the 25 tests. The vertical axis is the number of misfit items. If you look at some of them, it seems like some of them are above 30, right? Remember our GAT verbal, we have 52 items, okay? Calm down, okay? Calm down. Do not panic yet. Same, we have a big problem. I calculate the mean. The mean is about 18. Which means about more than 1/3 of our verbal items, they don't fit the 3PO model. Okay, that sounds scary, right? Can we still use the 3PO IRT model? Okay, so that's the thing I panicked at the first, when I first saw that. Okay, but if you think about it, let's go to the next slides. So seem like bad news, huh? So should we do, throw a fit like this or like this? Or maybe we pull our hair out while sitting on the floor like the little girl does? Or we try to cover our eyes and pretending it's not true? We don't do those things, okay? Why? Because, not really. Why? Because this is probably the most famous statistics saying by this guy, George Box. All models wrong, but some are useful.
He's very old.
Oh, yeah,
That's what I meant with mine.
Dr. Fassel, he passed away in 2013. He's almost 100 years old. And he's a son-in-law of the modern statistical father, Fisher. He's a son-in-law of his. He's a former professor at University of Wisconsin-Madison. Okay? So all models are wrong, but some are useful. Actually, this item fit, I did that while I was working at Prometric. You know, just flagging 1/3 of the number of items is normal. You know, because it's just based on statistical test. Okay, that's why CTO guys do not throw a fit yet. Okay, and let's look at some other reasons. Why? Because items being flagged as misfit ones only suggest that they do not align well with the 3PL-IRT model. It does not mean they are bad items. Okay, that's my first argument. Let's look at one real item. You can see it's from verbal test 1111. It's test item 10. If you look at this from the CTT, okay, we have the low ability, middle ability, and the high ability. And the correct response is D, this one going up. Seems perfectly okay, right? If you look at the distractors, everything is decreasing with the ability increase, right? And if you look at classic stats, it's awesome, right? The 0.50 is 0.45. That's pretty good.
Interrupt you for a second?
Of course.
I really thank you for this example because this is basically the base for the philosophy of the next development of the delta scoring. And you saved it, actually some effort to demonstrate.
Okay. If you want, I can sell the slides to you. Okay, thank you. Anyway, you see the p-value is 0.7 is reasonable. It's not too easy. And the point, I really like the 0.50, the 0.45, right? It's decent. It's really good. You know, you reach 0.4, 0.5, the 0.50 is really good. And if you look at the ICC, you know why it's flagged? Because here, you see, it doesn't follow this curve. But if you think about that, the empirical curve has a steeper slope, means has higher discrimination at a low ability level. So although it doesn't fit, it's not a big problem. It's a good item, okay? This is my first argument. Okay, let's look at my second argument. Items are flagged as misfit based on chi-square significance testing or in any significance testing, which, as is known, does not always translate into practical significance. Okay, let's think about, thank you, the diff. We have mental hazel, right? We all know that, but ETS come up with this famous effect size, right? Small effect, moderate, and large. Why? Because we really care about the effect size. You know, if the effect size is small, who cares? It's not gonna matter anyway. Okay, that's the idea. So let's look at another example. So this is another item. This is from 1101 verbal. And the item 4, you can see from this, it looks reasonable, right? The correct option is C. You see it goes up. The discrimination is good. The other distractors seem reasonable. And then let's look at the p-value. It's awesome. It's awesome, right? This is the ideal baby you want to have, right? P-value in the middle and the 0.50 relatively high. Okay, and let's look at the item fit. I don't think there is a problem with the fit at all. Okay? You know, all chi-square testing, our sample size is big. You're always gonna, be very sensitive. In this case, it's absolutely okay. It's absolutely okay. So that's my argument. Although it seems that we have large number of, the mean is like 1/3 of the item number, they are flagged as misfit. But it's not really that many, okay? But however, I think such item fit detection procedure can be used as a screening tool to flag items for further examination. I think that's important. I think that's all the testing industry in the States that are doing that, okay? And based on what had been flagged as misfit items, I visually examined each one of them and concluded that only 52 items warrant additional inspection. So if you think about it, we have 25 tests. 52 is like every test we have about 2 items. That's not really bad at all. And here I'm going to show some examples, show that this method does, allow us to look at some, bad items. So this is example 1. Okay, this is its, ICC and empirical response curve. You see here it's kind of, after reachability 0, kind of go down slowly. So this seems to be a problematic item, right? And if you look at its distractor analysis based on CTT, you see the correct answer is D. And it seems like A might be the correct key, right? We might have a key error, maybe not, but so this is you look at this, you see this item probably, definitely something is not right. And if you look at the classical stats, the p-value is 0.27, the 0.50 is 0.12. this is definitely the item we need to look at. And especially, I think, we need to involve our content experts to look at why to reach here, high ability students, they tend to, respond, to less successfully. Is there something confusing about this item? That's something we have to do. I mean, this is like an in-house procedure. Okay, let's look at example 2. This is another item, okay? So if you look at this item, same we have might we call the fairness issue here with this item, right? You can see that, response probability kind of decrease with the ability, increase, starting from -1 approximately. If you look at this, this is distractor analysis based on CTT. If you look at this, I don't think we can see any problem. You see, it seems the correct response is D. Seems it's okay. The other distractors, they are reasonable. There is no way for us to flag that. If you look at the classic, the p-value 0.5, the point by 0.13, it's seemingly low, but we still keep it, right? So my point is if we just look at those, we might not be able to detect this, okay? Detect this. This is another example, okay? So if you look at the ICC, the problem here is, when your ability is at -2, you seem you have a relatively higher probability of getting right. But when you reach to 0, kind of goes down, right? That's why it's flagged. This is the red, those black circles, and those are empirical things. So it's not posed on model. So it's just what we have in the data. And if you look at this, CTT distractor analysis, okay, so A is the correct answer. Seem reasonable, right? Kind of go up. And the other distractors seem okay. And the CTT value, the p-value, 0.23 p-value, and the point by 0.27. Okay? So we might want to look at that. Why the low ability at the end, they have a slightly higher probability of getting that right. This doesn't mean we have to do anything. It might be okay, but I'm saying it's important that we exercise caution to check those items, to really, to as a additional layer of procedure. Okay? So this is another example.
We say that lower achievers can
Guess? Okay, so yeah, there might be a possible explanation. The low ability, they have no idea, so they guess. Somehow their random guess has higher ability of getting right than those people in the middle. That's an alternative explanation. But I think it's important to exercise those kind of routine procedure to understand our item. Okay, thank you, Dr. Sharmani. That's a very good point. Okay, this is example 4. Okay, so this looked like, the first time I saw it, I thought it looked like the inverted Nike's logo, right? Kind of the other way around. Anyway, so it's same as before, a slight decrease of probability after you reach ability 0. Okay, this is the same CTT distractor analysis. Correct response is B. You see, it seems reasonable. And the p-value is 0.5. The point by 0.13. Okay, so one last example before you guys will go to fall into sleep. Okay.
But like even for the classical test theory, once we see a p-value around 50, and that's where the discrimination should be maximum. Once you get a low discrimination,
yeah.
This item I can assure you that it has been deleted.
Okay. I'm just saying, yeah, Dr. I agree with. I'm just saying, this is just we need to add some additional thing to check. It's not like saying, we are really, it's not that serious. It doesn't hurt to check. That's my whole point. Okay. So the last item we have the same, and keep in mind for every test we have only 1 or 2 items. And based on my experience before, and look at Prometric, they do have tests for like actuary, those high-stake tests. They also have items like this, okay? So it's not like items, the interaction between items and the students is extremely, extremely complex. All those models are very naive simplifications. So it's not gonna capture all what is going on under the hood, okay? Okay, so this item, p-value 0.65, 0.18. Okay, so enough examples. My conclusion is, okay, sorry.
Did you
This, Dr. Abdul, I think those items, I don't know whether they are deleted. I just got the data, so I just look at the data. I think my idea is to give like.
Could have, or maybe now you could, communicate with the scoring department and ask them by item number 46 or what's the standing? Is it countable or deleted?
Okay, Dr. Abdul, I'll do that. Yeah.
I mean, what has been deleted and what you suggest
Okay.
to be deleted?
Okay. Yeah, Dr. Abdul, I agree with. But I think we can do it in a better way, which is when those items are trialed, we can implement this procedure. So even before they get into the operational stage, we can flag them and delete them, right? So instead of at the last stage. Okay, I'm pretty sure those items, they have a QC procedure to make sure, some items are really bad is going to be flagged. Like I said, 1 or 2 items each out of 52, okay? So this is the thing. So my conclusion here in this part is, as can be seen from the preceding examples, the traditional CTD-based detection methods can fail to detect those items. I mean, right now, what we are doing is absolutely okay, because we are not really using IRT for scoring. Not yet, right, Professor Dimitrov? Are we using IRT for scoring already in operational test thing? Are we already using IRT for scoring students right now at the operation stage? So not yet. So it's not really an issue. I'm just saying if we are going to use IRT, okay? That's my point. It is critical that some routine in-house procedures are implemented to flag problematic items for further inspection. Like I said, especially at the trial stage. After trial, those are the kind of thing I think we should be doing, okay? Okay, so with that said, let's look at the third part, which I think is really what I want to emphasize today. So I'm thinking we need to implement some in-house procedures above and beyond in addition to what we are doing. Okay, I have a picture here. So this is saying this is what a person does on a regular day, right? You get up, you get showered. I'm just saying it should be routine.
Just before that, is there any, cutoff or misfit? As you explained some examples that's been classified as misfit, and yet they are okay.
Dr. Fez, they are.
Is there any degree of misfitting? Is misfitting just general judgment?
So they are flagged out of statistical test.
Yes.
Significance, that doesn't mean they are important.
Not the same.
They are not the same,
Some
absolutely.
are very far from fitting, some are...
Yes.
So can you draw a conclusion that if we are not away from this number, for example?
Effect size.
Yeah, I don't know exactly what's the misfitting measure is there, but can you make a conclusion that if we are in this margin, this might be, should be looked at. If it's less than that, no problem.
Dr. Fez, unfortunately, based on my knowledge, I don't think there is any, because item can misfit in many ways. It's really hard to come up with the effect size. That's why they keep saying it's important to do this visual inspection. That's my whole thing.
Give an example of the ETS effect size.
That's for diff. Diff is a different issue.
But not for
No.
I share with the same notion that at the end there's no magic number you would find to say this is okay and it's not. But one of the important thing is we have to differentiate between practical and statistical significance. Sometimes you would find this parameter is statistically significant, but it's practically not. So this is a good thing that we cannot rely on machine always. We have to use our mind.
Yeah, that's a good point. Dr. Abdullah, if you remember, go ahead, Dr. Fez.
Even the things that you showed us, it can be programmed and implemented as a machine.
But it's hard to...
It's not a magic,
But you need to have a number, a yardstick to compare against. That's the hard part because they can misfit in million ways. We don't know how to.
Yeah, for example, now you have monitored the performance of the alternatives and how they are like decreasing, increasing. And that can be programmed.
Oh, you mean the graph?
Yeah.
I program that. I'm gonna show later the reports you are gonna get. I program the things I propose here, but I'm just saying, Dr. Fitz, like this item, I think maybe it's okay. Like based on Dr. Shamrani's. Yeah. So there is some arbitrary judgment there. We have to make those judgment calls, by communicating between content experts and the psychometricians. And Dr. Abdullah, if you remember last year at the conference, we had this SAT, technical meeting. I asked Mary Petoniak and Kathy Shia, what are we gonna do with the fit items? At EDS, they do the same. They perform visual inspection. I remember that very clearly.
Also, she suggests this one, ST, in that time.
Suggest what? Oh, Orlando Thiessen, S chi-square? Yeah, that's the industry standard. Yeah, like I said. Yeah, and that's why I'm proposing this because Excalibur is using this box chi-square thing. Like I said, this one is clearly superior.
Can I just add that I think after you come up with when you do this inspection, we'll come up with some kind of ideas about what's happening with the items when they're not fitting. I think it's very important also to feed that back into the item writing and review stage.
Yeah.
Because you will minimize.
Yeah. It's a.
We can do a committee to study all these type of problems and sit with the expert, subject expert, and see how we can interpret that based on regarding the stem of the items and see why we having these problems. I think doing that will help us to avoid such problematic with these items.
It should be an ongoing recursive process between us and the test developers. And there is very likely we are not gonna figure out what is causing those. But it's definitely worthwhile, those. It's same as like we have been doing diff for so many years, but people have huge trouble trying to figure out what is causing diff. Statistical phenomenon and the real interpretation, they are really hard to come together. But it's still worthwhile. We need to do this, and it's not just one-time thing. It should be recursive, ongoing. We have a problem. We communicate with our item writer, test developers. That's what we do. That's what they do. In testing organizations. So that's I think we need to have something like implemented as a routine. Not like we want to do this. We pull out a test. We do it just for one test. We need to do it for every test. That's this is the large picture I have. That's.
Excuse me. And this done before publishing the results?
Ideally. It's like when the items are trialed, we can look at them. If we think a big problem, we don't even put them into operational. Because if you put them into operational and later you find out you want to delete items, there are difficulties because we have parallel forms. If you delete one here, there, are you going to delete another one? Stuff like that. Okay, so I think it's better to eliminate those items at the trial stage. Okay, so this is what I have in my mind at the trial stage.
During your study, did you see the performance of the items during the tryout or the actual? Is there a difference?
I only have the real data. Okay, I don't have that. Maybe later we can look at that. Well, there are sampling fluctuation. They are not gonna be identical, but they should be very close. That's my hunch. Okay, that's my hunch. But we can definitely look at that. Okay, so the third part, that's the part I want to emphasize. Like I said earlier, those are the procedures we should do like we do on a regular day. We get up, we take a shower, brush our teeth, we have food, we come to work. That's what I mean by routine in-house, okay? Okay, so before we do that, since we are very good at testing organization, I think it fits to give you guys a quiz, a multiple choice questions, okay? So which one of the following is the most valuable asset to a testing organization, okay? Option A, psychometrician. Weird people like me, got excited about weird stuff. And by the way, the psychometrician is like a buzzword in this organization, but lots of... Yeah, but lots of English native speakers, they don't know this word. You know, I went to apply for visa to the States. The visa officer asked me, oh, you are a psychometrician, what is that? I'm like, we go by psycho also, you know. Anyway, luckily he gave me the visa. Okay, so this is psychometrician. Okay, this is option A. Option B, test developers, you know, the group of people, hard workers who are trying to write really awesome items. Or managers, you know, the people who are being lead of projects and making sure our organization is running smoothly. Or D, items. Which one is the correct answer? Okay, no credit here, but you know, it's kind of an interaction. Probably you could tell that D is the answer, right? Items. Dr. Butter, what do you think?
I think a combination of both, all.
Oh, yeah, I like that answer. I like that answer.
Give item 90%, 10% for the free.
Okay, okay, nice.
Manager says the correct answer.
Yeah.
Because manager can bring psychometricians know that we need them. Psychometricians will also bring good developers. And the items is the result.
As a result of those ongoing efforts, right? Okay.
Can we go to the pictures? The previous.
Oh.
But this
Managers
question is
should go to the last one.
Oh, okay. So managers are doing the last one?
Yeah, do the last one.
Okay. That's nice. Okay. So I think we have a smart bunch here. We all figure out items should be the most valuable.
There's a compounding effect between B and D.
B and D, test developers and items, right?
Developers, they do affect the item.
Okay. Moderation, huh? Moderation there. Okay, so I think it's intuitive that items. Anyway, for any testing organizations, the items are like the highest security priority. We need to put them behind safe, stuff like that. The same thing we do here. So why items are so valuable? If you think about that, all the psychometrics, whether IRT, CTT, whatever fancy test assembly solver, whatever we use, they are based on the assumption our items are of quality. Okay. Mark Ruckis, a very famous psychometrician, once said that he was commenting on the computer adaptive testing algorithm, but he said, your algorithm, no matter how fancy it is, it's only as good as your item bank. What's in the item bank? Your items. If you all have really low discriminating items, no matter what kind of fancy algorithm you use, it's not gonna save the test. Even Trump can't save the test, okay? So that's the idea. I think so. It's no exaggeration to say items to us is our precious babies, okay? I think that's definitely not an understatement, okay? Okay, it's our precious babies. Oh, by the way, you can say this is really a bad item, right? A, B, C distractors are all people, and a D item is not people. So maybe I'm an okay psychometrician, but definitely a terrible item writer. Okay, it's a bad item, okay?
Is there any copyright on this one?
Let's pretend that's not the issue here. I got that from Google. I tried.
sleeping guide.
Okay.
Sleeping guide.
When we are not using them, they are hibernating. But when we need them, they come to action. Okay.
Very peaceful one.
Yeah. Very peaceful one. At peace.
It takes a village to grow a children.
We have an organization with more than 300 people. That's a reasonable sized village, right? So,
We will be the grower.
yeah.
In real life, babies are rarely sleeping like that.
Okay.
Test developer is very important, most important. But if he's not happy with the manager, they'll have كثير مشكلة. So.
But the question is, can we
So
produce?
they're all important.
Okay. Okay. Alrighty. So I think everybody agrees that items are like our precious babies. So how to make sure our babies are healthy and okay, growing okay? So this is in real life we do. We do what? We check them up. We do regular and routine checkup like this, or all kinds of checkup, right? Like this, okay? And we are hoping our items are not gonna have a grumpy face like the last baby do, right? Hopefully they're happy with what we are doing to them. So similarly,
How about feeding? No feeding.
feeding, that's behind the door, okay? Okay, so Yeah, just. That's why the last baby has a grumpy face. You know, you are testing me all the time without feeding me, okay, giving me toys. Okay, similarly, we are gonna do the same in-house item analysis procedures. So I think there are 4 that should be in place. First one is item fit analysis report. So this is based on what I showed earlier. Then diff analysis report. I mean, diff now for us, it doesn't cost us anything to do that, as I will show later. I think I presented on this last year. And then the distract analysis report, which is I presented in May, if I'm not mistaken. Okay, and then the form comparison report. I think we are already doing that, but I just automated that. You know, because we have same test, 5 forms, they are in different position. So doing form comparison is basically look at whether the item positioning effect is important. Okay, I think we are already doing that, but I try to do it in a more efficient way. Okay, so those 4 reports are what you gentlemen have in your folder. Okay, I give you just, I didn't print out the whole thing, but some part for you to take a look. So first part is item fit analysis report. Here's an example of get verbal. So you'll get something like this. Here is just some introduction if you want to use that as a kind of a tutorial. Then starting from page 2, you have 4 items, 1 page, showing their ICC with those things. It's very easy for them to, you know, to visually inspect that. But keep in mind, this is based on the flagged item. If it's not flagged, we're not gonna even bother, okay? So we can imagine each different test, they have a different page number because number of unfit items might be different within each report. You have a question, Dr. Sharmani? No. Okay, I thought that, okay. So this get, we have another, I only did 1, get quant. You see it's exactly the same structure, okay? But you know, the items are, of course, quant items. So that's what I have in mind, the item fit analysis report we should have for every test, okay? We should have. And the diff report, we have 2 diff reports. And we have 2 diff reports. The first one is for our test developers. If you can see on your, you know, diff reports for test developers, it gives you like the difficulty, the discrimination, and how many diff methods has flagged it as significant. In total, we have 7. So if you see something like 5, okay, you might want to, you know, dig into that. Then we have the diff effect size, you know, based on the ETS, the delta score. This is you know, for test developers. For test, we have 7 methods. You know, the idea is that, you know, in the diff literature, there is no conclusive finding that which diff method is the best. So I think, you know, it doesn't hurt to have all kinds of information together. And my idea is that if the diff effect size is really big, no matter which method you use, it's going to show. Okay? Again, you know, significance against practical significance, statistical versus practical. Then we have a second report. This is for our psychometricians who are interested. You know, it gives you all the 7 methods. Okay? Which one flagged it as significant or not? And also we have number of diff has been flagged and the diff effects. So those, I think, if we have the gender variable, those things can be done fairly easily. You know, I program this to produce 2 reports like this. It take maybe for one like a GAT with more than 70,000 students. It take maybe 10 minutes to produce a report like that. You know, you can just automate and let it run. Okay, get the results and, you know, and talk about it. This is a diff report. Okay, we have 2. I'm not gonna get into those detail of those 7 methods, but it's a good combination of IRT-based and non-IRT-based. And the mental hazel is the second one. You know, I think you know, if you are really into that. Okay, so the third one is the distractor analysis. I think since the last presentation is in May, it has been half a year. I think it's worth a little bit revisiting. This is what I do. Okay, imagine we have a hypothetical math item. Okay, here we know the correct answer is A, right? But you know, some students might choose D because they do not know to change the sign. So you might get something like this in terms of distractor analysis. It tells you like for each option how it, you know, its response curve, how it goes with the ability increase. And if you look at that, you can look at a D. Is this a purple line? So it kind of goes up. Because students do not know change the sign in the item, they still know, -3 minus 9 is -12. So they still have some ability. So this item, you have something like this, kind of help you to, understand what is the misconception, okay? So it's diagnostic. And you get the item information for each option. This is what I have in the second report. You have that there. And, okay, so you might say, why not use distractor analysis report in CTT? This is based on CTT. Can you tell they are the same item? They are the same item. The only difference is that when we put students into low, middle, and high ability, we use different methods. This one is based on, say, imagine we have a test of 60 items. This low ability is students get a score of 20 or less, okay? This is the first way to grouping examinee. This is like, I say the bottom 30% are in this. Okay, so it can be arbitrary and confusing. This is a CTT thing. That's why the second one, this is a real item. If you look at this 1101 verbal item 10, what you could get out of this, other than the CTT thing, is like the green line here. You can see that it reach a peak, then go down. If we look at that option, I'm pretty sure it's a very well-written option that really addresses some misconception. Students need to get there to be able to choose that option. If you don't even have that ability, you're not even going to choose that. But after that, you know better, you choose the correct option. With this, you're not going to get that. So this, I think it's important to have this also like embedded in our thing. Okay? So you get, you also get item information function, get option. That's everything is in the report. The second report there you have. Okay? And so as a result, I'm going to show some examples. This is like a GAT. Since I've done this for a while, so I produced, I think, 50 GAT reports like this. Then we have SAT, which I think I produced 16. The same structure. You have only one example by the STEP, I think I did 32. Okay, those are the reports there. Okay, you can take a look. Exactly the same structure. Okay, last thing, form comparison report. So I automated this thing. If you run a GAT large data set, it takes 3 minutes to generate something like this. You see, you have form A, form B, form C, form D. You have p-value, point by zero, whether it's flagged. Before, they had to print out 5 reports from item map. And it's not easy to check them visually. With this, you can directly compare. And you can see they are pretty good. They are pretty much the same. So no item positioning effect in this case, we can conclude. Yeah, okay. So this can be automated. What I mean is we can put 20 tests in that. It runs the same. You just click run, you come back, everything will be ready for our test developers to check, okay? So last thing I want to say is the importance of automation. Manual manipulation is okay with the small scale tasks that are not routinely performed, but like what we are doing at the measurement department, statistical analysis unit, they are doing this. Say we have large number of tests. You do it manually, it's a probability issue. Eventually you're gonna make mistakes. And for a testing organization, we don't want to do that. So we want to automate things. And it is desirable to use software programs to automate routine tasks to minimize the probability of making mistakes by doing it manually. The good thing so far, I think most of the routine tasks that we are doing in the statistical unit, everything is automated. Is that right, Ahmed? Pretty much? Yeah, so make sure, no manual, no like a copy paste. Everything is automatically done with through programming. That's what I have, I think that's the good news. Okay? So long presentation, and so final note. Okay, so those routine in-house reports I think are not produced to replace the current ones. I'm not saying the current ones are bad, okay? It's above and beyond. They are intended to provide complementary information. That's the whole idea. They can make our tests psychometrically more robust. And they also provide learning opportunities through which our test developers and item writers, they can develop better items by looking at each option, get more information out of it. Okay? So this is the reference. If you are interested, I can send this to you. And by the way, if you are really into IRT, I think the second reference, D. Ayala 2009 book, that's a really nice IRT book to learn about the basic concepts there. Okay? And this is, that's it. Thank you. Hopefully it's not too long.
This preliminary examination of the quality of the item, not just fit, because the quality of the item goes beyond the fit, and I like two key statements that were, in your presentation, that known in the literature, but people typically, they're so obsessed with IRT that they forget that, the models, all models are bad, right? And the misfit does not necessarily mean bad items. Those are key statements. And our delta development will actually rely a lot on this philosophy, this wise philosophy of practical importance of significance. However, no matter what we do, a preliminary analysis of the quality of the item is extremely important. And I find this structural analysis also extremely important. Maybe one of the first pieces should start from here.
I presented this in May. While you were away, so.
And now
I
get
right.
to the point here that here you have ability, right?
Yeah.
We may just repeat this analysis where ability will be the based on the delta square.
Sure. It's just a scaling issue. It's very easy to change that. Yeah.
Especially with trial items where you have relatively small samples, and the accuracy of IRT estimation, especially for theta, is very shaky. The ability based on delta scoring will be extremely valuable here in this analysis. So on the horizontal axis, we'll just put delta, and next time I would like to present the structural analysis based on delta.
Sounds awesome.
So,
Thank you.
okay.
Thank you.
I really would like to thank Dr. Young for his
Thank you.
presentation, and not only the presentation, but the dedicated work to change the style of our inspection of our items into an automated process. From a long time where I was trying to make a diff analysis as a default, and it should be a default, and all the big institutions that produce high-stake testing, one of their ABCs is the diff analysis. So Dr. Young is making it easy for us now to just with a click we could do the diff analysis, and also the checking the forms. We were checking them manually before, and now we have cut down the labor work to maybe a sizable amount of time, and we really appreciate that.
Thank you.
And we have a lot of issues that we could adapt or try to change in the future, in the near future, inshallah. One major one, one of them is the conception of the scoring system with Dimitrov. And I don't know, are we going to say label it a delta score or a Q score? A KS score. Because it's a new development which is really worth announcing in the near future to all the psychometricians around the world. So we really thank you for your efforts and dedicated work.
Thank you, Dr. Liu. Yeah.
Thank you for the presentation.
Thank you.
Really, what we are doing in measurement department, we try to automate all the process to do it. So whenever we have a number of the tests, we can do it in 1 day or 2 days to analyzing all that. So alhamdulillah, this is one part is really we achieve it. But also we try to involve some indices in the analysis, and we need to change the file analysis listed to include at least gender, the file analysis to do because most of our tests now are listed to the both gender. So inshallah we will ask the IT to offer some information, at least gender variables, and when we do that, then we will be ready to do all the analysis based on this.
Yeah, that's a good point.
Any questions?
Can we see, I don't need to repeat, my thanks to
Thank you.
and the team in the PS department to really make our daily work easy and systemized. And that's really an objective for quality and assurance. So we can continue doing the same degree of accuracy and proficiency for all our work, regardless who is there, who is doing it. And my question, probably, did you reach? Did you apply this automated procedure now to some tests so we can see the results?
You mean?
For example, you have showed us at the beginning that there is more than 30% or mismatch or misfit. By the procedure now, how many? What's the percentage of really bad items that you can? Recognize now by this.
52? About like 1 or 2 each test.
Out of 25 tests.
Out of 25 tests. So about 2 items, one test.
And that's after the deletion or before the deletion that we have done before?
What?
That's the same.
Yeah, without.
deletion.
Okay. That's good.
Because we give them the file analysis. File analysis, you don't recognize which deleted or all the items in the file.
Maybe I'll show you the code for the item.
Okay, that's good news then.
Yeah.
Maybe the general question now, it's not only for you, when we're talking to applicants or students who get to the tests, and we tell them that there is some items for trial, for tryout, and some items could be deleted because the performance is bad. They answered, why you tortured us for items that not be counted in the test? Because those items might take time from us. Based on their statistics, maybe they are really bad items. They take time. It's not clear or so. This might take time from the students more than a regular good one. Is that, according to fairness, and maybe can we overcome this difficulty or this problem?
Yes.
And what we can answer them? Because probably, the tryout items are not the same for all folks. So maybe if you are, if the tryout items in one section, that's no problem then. But if they are mixed with the real items in one section, in the same section, that's really the problem. I think this is also in future tests. They are mixed with real ones. So I think there is a problem in mixing the tryouts with the real ones in one test, one section that's with the restricted time. Just, I want to.
Sure. One appropriate moment is when you have operational license and you add one trial license, right? Then at this point, the characteristics of the trial items based on the total set, which is very good and dependable estimation. And this way, people can make decision what to do about those trial items. But let's make sure that whatever the statistics are, there's always need to coordinate with the item writers and to examine whether if I kick this item out, this will hurt the content representativeness or something that is targeted by this item. So we don't have to just rely on statistical, say, indices to kick the item out. There should be always coordination with the item writers. Should be very careful work. Because again, a misfit does not necessarily mean a bad item. That's and I'm kind of thinking this along for a long time, but maybe we will get this the practice of re-examining trial items. Yes.
I think, maybe one of the reasons why we did not raise the cost of the test is the item tryout. So this is maybe one of the things. But when it comes to real work and professional work, trial items has been used and always, in big, institutions like ETS, ACT, all the respectable institutions, they introduce trial items within the test. And this is a standard, process throughout the professions. Usually, we tell people and students that all our test has trial items inserted into it, and they know about it. So it's the ethical issue is not there because they all already know about it. And if there is an effect on the performance, it wouldn't be on one person. It would be for the whole population and will show up in the result of the test. So I don't think it could be a problem, or at least if there is a problem, it would be for all of them, and it will be cancelled out then.
Yeah.
May I add? Thank you. Just a small point to add to that is you talked about feeding this back into the analysis from trial items, which may be problematic for one reason or another, to feed that back into the writing and reviewing. If that is done as a constant thing, then the number of trial items which will be problematic and may cause problems or confusion, that would be minimized.
Yeah.
Because the major organizations that have a success rate of 95% or above for their trial items. So they are like real items, more or less. And if you think about 95%, then you will get one in each test, maybe, or something which is not working, if you are working in this way.
The idea is really get rid of those bad boys before they reach the operational stage. That's the objective.
Or even reach the trial stage.
Yeah.
But, how much is the bad items in the trial? How many? What's the percentage of that items that dropped out in the trial stage?
Not much. Well, not too much. Every كل فترة we throw away like 3 items, 4 items. Not too much.
It's about
three from 25.
It's about 5.
Every item.
3 from
3 out of what?
25?
About 5%.
5% of the total.
All total.
أي of course. ما هو
We
it's
can
not that
count
much.
it. We have
But it varies from test to test. They are in the mood, But usually we never get more than 10% out of the total test.
يعني if you see يعني the last 3 kind of examinations, we throw away just like
we ask about the
any time.
No, they ask about the trial items.
Trial items.
Ask the trial, where is
In
it?
tryout sections.
It's mixed.
I follow the trial items.
So if you want it, we have report for that. We can
We can produce report for each.
we have reports for
And we monitor that for the seriousness of the.
Also, Doctor, this report sent to each subject department. We tell them this, that right, this bad item, you should concern about it, to develop their writing.
Okay, as Dr. Bjorn said, if we minimize the not good items in the tryout, this will be the best. Dr. Faisal question, shall we put it in one section or we separate it as in the teacher test in all sections? Okay, to take it, to be fair, so it has to be in separate section, okay? But these tryout items, it has to be taken care by the students, the test taker, to make sure that they don't know that they are tried.
Yeah.
If you separate it in one section, it's very clear to be identified with time. This tryout. By nature, they will know. So in this case, they will not be serious. The students will not be serious in solving these tryouts. So we come back to his original question. I spent a lot of time to solve bad items. Actually, one of the techniques, you have to minimize your time in the test. The test is 90 items. So you should not spend too much time on one item and you leave the 89 items. So this will compromise the concern that we might be not fair. So
Okay.
this
It's a very, very good point, sir. I think I want to say something to address Dr. Faisal's concern. Like you are concerned about the time factor there, right? So the industry standard, what they're doing, like a big testing organization, they apply solver to a simple form. Then within form, of course, we have trial items that embedded there. After that, they ask the test, the content experts to review each form, the sampled form. That's what they do to make sure, using their expertise to go, hey, this item might be okay. On general, they are kind of balanced out. That's one way to do that. There is a relatively new approach proposed by Wim van Rinden. So he has this item response time modeling. So if you do record each item, how much time they spend to answer each item, you can fit the model and estimate the time intensity of each item. Then when they assemble test forms, they take that into consideration.
Yeah, that's possible if we try them out in the computer-based.
But before trial, we definitely,
possible. But labor convention.
But you can select the right example and
but still cannot get around the issue. They have to be trialed first to get their time intensity estimates. So, but
Yeah, but if we can put the tryout items in a separate section, that of course the student should not know that it's tryout. Of course. And then this is, I think, the ideal.
this is
GRE before, they put all the trial in one section. So if we design that carefully, they cannot tell the difference.
You need to have a rotated design in large-scale testing. You need to have a rotated design. You can't,
That's what they do to make sure you have enough sample size. So it's a separate section, like the old GRE. When it's computer adaptive back then, it's like a separate section. Whole section is devoted to trial. So my point is, if we design that carefully, they might not be able to tell the difference. But the format and structure, everything has to be identical. Otherwise, they can't tell. So that's it.
It's a great idea, but what about the fatigue factors? Once the students end up solving the whole questions, if we leave, for example, the tryout items at the end of the sections of the forms, they will get like fatigues.
It's random. Its position is random.
No. I'm saying if it's not like mixed,
It's a section. You're saying?
Unless it's like at the end of each section of the test, you will get like a chunk of trial items. This way, it's okay.
It's interspersed within the whole test. So, and to address the fatigue issue, I don't think fatigue is, whatever test you take, you have to make efforts. You have to make efforts. All we have to do is make sure they have a reasonable amount of time to answer each question. Because fatigue is always an issue. You can always argue that fatigue is an issue. But we still have to do
Fatigue
that.
is also, opposite to it is the learning
Learning curve?
curve, yes.
Okay.
I can do better at the end of the test, more than at the beginning. I just am heating up on learning how to deal with the time and so on. So
Less anxious.
yeah, so I think it's cancelled out.
Yeah, and then this way, then it's fine.
You can't, the trial items, you can't put like any one position in all the tests because different factors can influence the properties of the trial items. You have to have them rotated, across the length of the test. For instance, you said, yeah, you heat up, but many people are short of time, kind of, they're running late, and if all the trial items are at the end, the time factor will take, come into play, and then you start spending less time on each item. That's going to influence the properties of that's going to influence the item parameters.
No, I mean as the whole section. The whole section with defined time.
You separate
Yeah.
the trial out items.
If the structure is identical, I don't think there will be no problem.
If it's well designed, I think they should have enough time. That's the thing we as a test maker should really consider in the first place. They have reasonable amount of time to answer the questions. If they do not have enough time, no matter what kind of design we have, it's not going to save it. So we really should make sure they have enough time.
Before, I don't know if you allow me, if there is no more questions, I can talk. At the beginning in GATT, we put the tryout items in a separate section. We mixed verbal and quantitative. And the other sections are dedicated either to verbal or quantitative. So there was a really big gap between the tryout setting and the real setting. Because you try out the items while you mix them up with verbal and quantitative at the same time frame. While in real sections, you separate them. So we found that the readings parameters for items are changing.
But they were
I found out that verbal is the B value for verbal items is, when you put them separate, they get higher, and quantitative items they get lower. While you mix them, now the setting right now is the mixing out, even the real ones.
Yeah.
So we now it's become very close to the tryout setting, exactly the same, because you are mixing them in the tryout setting and the real setting. So now it become like averaging. The verbal is decreasing a little bit and quantitative is rising, because students really are managing their time. They use the time for verbal items to more to the quantitative, because they need more time for quantitative items. So they manage their time. They devote more time for quantitative items. So they could reach to write answers in those items more than before. So it's very sensitive, it's very sensitive.
But even in the old style, we used to have mixed sections of verbal and math.
Except in isolated.
Yeah, I know the form that you are talking about.
Tajribi and in the tryouts, they are mixed, but in the real sections, they are separated.
Right, but there was a mix. Even in the trials, there were sections that are verbal, sections that are math.
One section.
But there is one section that is mixed.
And whom isolated.
That's before.
We had like
six sections.
Before.
After we changed to 5 sections, no, it's only the tryout. And also this is a problem because they can't tell that the mixing section is the tryout, so don't care about it. So now they cannot tell, so they do their best on those items.
I have a question for maybe easily one, but I just want to ask, is there a way to integrate the trial items with the regular ones and deal with problems in trial items later? If there is any problem, if there is there a formula, a statistical formula or whatever, that can correct the effect of trial items, if there is any?
Or you know, you make it in a way that students might guess. Even they may guess wrongly. But don't go, if you give them the chance to say, okay, well, this section looks like a trial. So I'm not going to put much effort into it. Although the time slot is assigned to this section only.
I think with computer-based we can, solve many issues.
Okay,
Overcome a lot of problems.
do we take this as an okay for me
Yeah.
to start
Well,
trying out?
Next week, we'll tell. Step. Try out.
No,
Right,
I we're asking you. Is this
By the way, do you want good news or bad news? I don't know.
No, I want good
For
news.
step,
Nobody
new
wants.
version for step. I will tell you about it. We have deployed the new step setting.
Yeah, we did.
I will talk to you.
I think last week we started the new set.
Okay.
Okay, done.
Now, to be more seriously, your question is very good. And there is a way we can do this, but then it will be extremely difficult to explain to the public, those stakeholders, why we're doing this and to what degree this is fair or unfair. That's the whole thing. Otherwise, yes, it's possible. Adjustment, corrections of this type, theoretically are possible, and we can put formulas, everything, but then how do you explain this to them? That's the major
You
issue.
can model that with the general reliability theory. General reliability theory, we can model it that.
We can model everything, but all models are bad.
But how
Okay, thank you very much. Thank you all. Thanks to Dr. Young for his beautiful presentation, and mainly his beautiful title of the presentation as usual. And thank you to you all. And now it's time to prepare for prayer, inshallah.
I just suggest that we do this structure analysis with the delta, and you send there's no need for additional session, but we can distribute this to the people here. Additional tables with the deltas going on the structure analysis.
Okay.
Right?
Okay, thank you very much.